Okay, good afternoon, ladies and gentlemen, on this first official day of spring from a decidedly cool Cape Town. My name is Robin Hayes and I'm the editor of Cape Business News, and it's my pleasure to welcome you to the second in a series of interactive roundtable discussions on South Africa's imminent water crisis. The topic for today's discussion is that of water reuse. Is it a salvation strategy to our looming water crisis? Most of us are acutely aware that unless drastic interventions are implemented now, we face a serious threat to water security, as predictions indicate a 17% shortfall between water supply and demand by 2030. That's less than 9 short years away. Without water security, our welfare and future growth prospects are severely limited. Water reuse is a sustainable technology which is used throughout the world to help meet water demand of growing economies. So why not here? In fact, in neighboring water-scarce Namibia, the Windhoek water treatment plant recently celebrated its 50th anniversary of producing safe, potable water from wastewater inflows. But why is it that South Africa is lagging behind? Is it that a stigma exists in that consuming or using processed wastewater is unhealthy? Despite tried and tested technologies which make this mature process a perfectly safe and virtually inexhaustible source of potable water. Following the Western Cape's water crisis, water reuse is now part of Cape Town's sustainable water strategy. But let's not wait for another drought to implement measures to protect our water security. So instead of wasting precious wastewater, what can be done to make water reuse part of every existing and new treatment plant, thereby capturing this critical commodity? Those are the subjects that will be addressed by our panel of concerned experts who will discuss solutions to this vexing issue, where we face up to the realities, discuss the solutions and how best they can be influenced. Critical influencers in promoting water reuse include community leaders, professionals such as architects and engineers, property developers, the agricultural sector, government and municipalities. They all have their parts to play in making reuse a reality by recognizing the imperative and explaining the technology. I'd now like to hand over to our moderator for this session, Dr. Nhlanhla Kalabele, who is the research manager for drinking water treatment and quality at the Water Research Council. I hope I've got all that right, Doctor. So over to you.
Thank you very much, Robin. Good day, everyone. Indeed, my name is Nhlanhla Kalabele. I work at the Water Research Commission, and there I'm a research manager for treatment technology and water quality. Welcome to this very important discussion on water reuse. And we have about an hour to delve much into more detail on water reuse within the South African context by looking at the opportunities that exist, and also looking at some of the recommendations or interventions that need to be put in place in order to fast track or improve the implementation of water reuse in South Africa. Now, I just want to first give a little bit of a context on the topic before I also allow my other panelists to join me in this discussion. So water scarcity is not just a South African problem, but it is a global problem. And this problem is caused by the exponential population growth, industrialization, and urbanization, basically competing needs for water. And also now we also know that climate variability and as well as climate change are putting a further strain on the available freshwater resources. So South Africa has for a while now been gradually shifting from relying from just surface water or freshwater resources for meeting the country's needs towards diversifying the portfolio of water resources that can be used to augment water supply. So amongst this, the treatment and reuse of wastewater has been identified and already has been recognized as a very important measure in addressing localized water scarcity in South Africa. Now, as you would have already heard from Robin, South Africa has been involved in water reuse for a long time, as old or as way back as the Namibian water reclamation plant. So in South Africa, the participation has been in terms of research. So if you look back in some of the published documentation, you will see that around the early 1970s, there was intensive research on water reuse in South Africa. And obviously the question that really is on everyone's mind is that if really South Africa had embarked on research as early as then, really what are some of the factors that are needed to actually speed up implementation? So water reuse, we know that it can be used for both potable and non-potable purposes. And also, apart from water reuse being an important resource for recovering water for reuse, wastewater is also an important resource for extracting other resources such as energy as well as nutrients. And as you can imagine, with recycling comes with it immense opportunities also for job creation. However, in order to realize all these immense opportunities and benefits that come with water reclamation or water reuse, it is very important that we look at some of the interventions or measures that we need to put in place in order to support its implementation in South Africa. So now, like I said, we have about an hour to delve into this topic in more detail, and hopefully we'll be able to address other topics such as to look at the types of projects that are being implemented in South Africa, and to look at public involvement in water reuse, and also how we can involve or attract the participation of all the segments of society in water reuse projects. And we're also going to look at industrial water reuse projects as well as mine water reclamation as part of water reuse. We're going to look at the opportunities as well as some of the challenges that exist there. So now, as Robin said, I have three fantastic experts to help me unpack this topic further. And just before I introduce the three experts that are on standby to really offer us some perspectives on the topic, I would really want to encourage or invite everyone else who is a participant to also participate in the discussion by making use of the chat function, where you can drop your comments or questions. And then a little bit later on, when we have the discussion, I'm going to pick up on some of the comments and then pose them as part of the discussion. All right, without wasting so much time, let me now introduce our very first expert in this topic. I'm going to introduce Megan Skalk from Umgeni Water. So Megan is a process engineer at Umgeni Water, and she is the current chairperson for the Water Institute of Southern Africa, WISA Water Reuse Division, chair for the KZN chapter, and she's also the vice chair of the WISA the branch, yes, the WISA branch. Then, yeah, over to you, Megan.
Hi, everybody. It's a privilege to be here. I didn't prepare a huge introduction because I thought we're going to have a discussion about the reuse, because reuse is very important, and it's the only sustainable way that we are going to ensure that we're going to have water and preserve our resource. when we're looking at reuse, it's not only just reclamation, but you also have to look at what, in terms of wastewater, what we're putting back into our resource so that we can preserve the resource for the future. So I'm really happy to be a part of this topic today, and I hope we can shed some light and have some really good discussions that can be taken forward into other initiatives later on. Thank you.
All right, thank you very much, Megan, for those perspectives. Next, now let me introduce to you Mr. Chris Schwartz, who is an independent water utilization engineer, and he is the former WISA Water Reuse Division Chairperson and is now a technical committee member. And he is currently the chairperson of the WISA Water Reuse Division Western Cape chapter. Over to you, Chris. Would like to hear your perspective on water reuse.
Very much, Nomslanhla, and thanks for the opportunity to be here today to take part in this event. I think it's very exciting that we can attract attendees from all over to listen to reuse so that we can spread the message. Thank you also to Cape Business News for facilitating this event and for making it possible. So just a brief introduction to the water reuse. I'll be looking more at the municipal water reuse from wastewater, treated wastewater. I think Achim will be more talking about from the mining and the industrial side. So if we look at the R's, reuse, recycling, resource recovery, rehabilitation, these are all the R's that I'm very passionate about in trying to conserve and save our planet from total destruction if we don't look at starting to recycle, not only on the water side, but solid waste as well. So working in the water sector, then obviously I've focused more on the water reuse side. So water and wastewater treatment, but later on started looking at water reuse, and then very specific, as I said, towards municipal water reuse. Now, Robin has mentioned that, and Nomslanhla as well. South Africa, or Southern Africa, has a rich history in water reuse, starting from droughts that were experienced in the 1950s and 1960s in Namibia, and particularly in Windhoek, where they had no other water. There were no rivers nearby, or there are no rivers nearby to Windhoek, and there's no other sources, very low rainfall, so I had serious problems. During that days, they started at the CSR in Pretoria to do research and development on technologies to treat the wastewater to a potable water standard, and specifically looking at all the health implications. That led to the first water reclamation pilot plant that was built at Victoria. Was called the Stana plant, and that led to the first plant in Windhoek being constructed in 1969. As Robin mentioned, it celebrated 2 years ago its 50th anniversary, and it's still going strong. No serious problems with any health matters over those 50 years, and providing a very necessary portion of water for drinking purposes to the Windhoek community. More recently, around about 2008 to 2010, there was quite a serious drought in the Southern Cape and Karoo area, and that led to the first South African water reuse plant being built in Beaufort West, and that was quite an achievement for South Africa, just demonstrating that it needn't be only in metro, in the cities where this can be done, but also in the small towns, you could do that. And that plant is also now in its 11th year, still going very strong. It was built in 2010. Other plants were also done during that Southern Cape dry period. Indirect potable reuse plant in George, and a plant in Mossel Bay as well that supplied Petro SA with water. Sorry, let me just get my place here where I was. Okay, and more recently then, obviously we had a serious drought in the Western Cape, closer to Cape Town, around from about 2015, which lasted to 2018. I just want to interrupt myself here to say, at the moment, the average dam capacity in the Western Cape is 102%. So we passed that drought period, but we've made sufficient, and we are making, sorry, I'm talking about us because I'm based in Cape Town, sufficient preparations that we're doing for, if we should, droughts like that should occur again in future, we can be ready for that. So feasibility studies were done in Cape Town, which led to the first demo plant at Zandvliet that was built, and the large plant is currently in tender stages and will be going out to construction soon. So in terms of technologies, talk together with the rest of the world. Technologically, we've come the way we experienced. We've done a lot of research, and most of this research was funded by the Water Research Commission, concentrating on aspects such as health implication or health impacts of reuse, direct potable reuse. And as I say, we are on the forefront and talking with other countries where they are applying it, like in the southern parts of the USA, Arizona, California, Texas, and so on. Also Australia, which we know is a dry country. A lot of work was done there, Southern Europe, Spain, Portugal, and those countries as well. Yeah, looking forward to the discussion session. It's not all just good with reuse. There's also a number of challenges that needs to be addressed. Some of those challenges are the public perception of water reuse or the public buying in, and also funded a number of studies in that regard towards getting more public buy-in. Cost of technology can be prohibitive in some instances. And then the regulatory aspect, obviously, regulating the quality of the water from wastewater treatment plants. So that is something that needs to be sorted out by our custodian of water in South Africa. Okay, so Nonhlanhla, thank you very much. But yes, just a little bit of background on reuse in terms of historically in South Africa. Thanks very much.
Thank you very much, Chris. That was very, very elaborate, a detailed account on water reuse in South Africa. Thank you. And finally, I'm going to also give Achim an opportunity to also give us his perspective. Now, Achim is an independent process engineer, and he is a former chair of the WISA board and also a former leader of the WISA Membrane Technology Division. We're very eager to hear from you now, Achim, from the industrial side or from the mine wastewater treatment side, on what really the perspectives on water reuse are and what the opportunities and the challenges are. Over to you.
Thank you, Nonhlanhla. Yeah, you know, there's lots of opportunities, and on the mining side and industrial side, a lot of them have been grasped already, and there's still chance for a lot more. Chris, you mentioned you've got these water reuse projects starting there in the Cape. That's good to hear. You guys always obviously still have the ocean as a backup plan if there's no, if you need to desalinate. Up here in the Gauteng area, in the inland, we don't have an ocean that we can desalinate, so we are forced to reuse whatever we have and make sure we use it multiple times if we want to meet the water demand in future. And from the mining side, I mean, this has been done for a long time now already. About 15 years ago, the first full-scale plants were implemented. The Malahleni water reclamation plant, then a little later after that, the Optimum one, and a couple of other smaller or similar sized ones since then. And yeah, it's been a very interesting journey on that. I've been involved with those from the early days. Technology choice, trying to cost optimize, trying to maximize the positive aspects of the project and minimize the negative aspects of the project. Brine handling for us is always a big problem on the mine because we've got salinity that we've got to take out. But on the mine water side, we have the big advantage. We don't have the endocrine disrupting chemicals or the chemicals of emergent concern. We don't have the bacteriological problem. So actually, mine water is actually quite an easy one to reclaim. And I mean, part of the early work on the pilot plant work, and then afterwards, when we had full-scale plants implemented, we did testing for, besides the normal chemical testing, we did testing for teratogenicity, so mutagenicity, check any cancer-causing things and anything in that lane. We looked for aquatic ecotoxicity there as well, and radioactivity, and no concerns there in the treated water. So, but I think Chris and Megan are a bit more up to date on what's the issues around the domestic water reuse. I'm looking forward to hearing their part of that as well. Then, yeah, I mean, I saw some points in the chat now about water reuse should be just fit for purpose when you treat it. And that's sort of the approach that the mines have been taking, where they can irrigate it and use it for irrigation. That water is sometimes used directly for irrigation, and that's a reuse that doesn't. But then you can also partially desalinate it, just good enough for use in the coal wash plants, and you do not need to take in other fresh water from other sources, and that water becomes available for potable use somewhere else. And then obviously we've been taking it all the way to potable, direct potable reuse in a massive scale, and no issues with that since that's been implemented. Yeah, there may be just another point to add from what Chris said. You know, the cost of water treatment for reuse can sometimes seem high, but if you once there's no more water, the cost of no water is even higher than the cost of water reuse. So we must just keep that perspective for now. And then just a bit of background, you know, where I fit in. I don't know where that's coming through everybody, but that's an approach that I love. So thanks for now.
All right, I would really like to thank my three experts for those very rich contributions. And I can see already there are questions in the chat. And just before we go into the questions in the chat, I was very intrigued by what you said, Chris. You gave us a detailed account on the implementation of water reuse in South Africa. So I thought that maybe even before we get to that, can you just maybe give us just just in terms of definition, an overview of what, when we say water reuse, we are talking about? Because I also had Achim also introduce a new term, desalination, and also now maybe if we can also start talking about the different types of reuse that can be done. And I've also seen a comment from Henny Roots, and he's saying that the focus on potable water reuse might really be a short-sighted approach. What do you think about that comment?
Thank you, Nansla. Yes, I think Henny is absolutely right with his remark there. I think in preference, if you can reuse water for non-potable reuse, that is for irrigation or other agricultural uses or industrial secondary quality use, obviously you can do that. You should focus on areas where good quality water is used, where it's not required for a good quality. And a very good example of that is irrigation water with high quality drinking water. So if you can reuse water and use it for that purpose, you will make that water free and available for the community. So that is quite correct. It's done that way. I think where you will need potable reuse is where you have no other choice. So all the other sources or potential sources are not available. And I think both of a good point in case there, where that Gamka dam was totally empty, 0% water in there, and the boreholes were starting to get dry as well. So they were necessitated to look at reuse for potable water. Once you get sufficient water back into the system from conventional or surface water sources, then you can reduce the percentage then again that you use for potable water then for non-potable reuse that I mentioned. I'm just trying to think of your other pointers or questions that you asked. So I think reuse is being...
Yeah, Chris, I'd asked that maybe if you can just start by just giving also a broad definition of terms, water reuse,
Yes.
recycling, desalination, just so that we know what we are talking about, and also so that also our audience can really follow on what we are talking about. Yeah.
Yes, yes. So reuse broadly is that you use water basically for a second time for a beneficial use. So you abstracted water from a dam or a river, and you used it for drinking water, and that water that's then discharged normally to a river after treatment in a wastewater treatment plant. And I must just mention here that we're not talking about wastewater treatment plants anymore, but resource recovery facilities. That's the latest, because there's a lot of resources, nutrients and so on that you can get from that water. So instead of discharging that to the river, maybe you can reuse that water for some of the uses that we mentioned. So there's potable reuse, so that you can treat it to a quality that it's safe for drinking by the community, or non-potable reuse, where you don't need such a high quality water, but you can use it for industrial process waters, for instance, irrigation, either in agriculture or in sports fields, parks in the urban areas, a number of other uses that you can use it for. So that's basically recycling more, where you return the water, for instance, in an industry. That would typically be more your recycling applications. And reclamation then is where you basically do it on a municipal scale, like in Windhoek and so on. You're talking about the water reclamation plant. But the interesting one there that everybody might not be familiar with is the de facto reuse. And that is basically unintended or incidental reuse. And that occurs where you discharge wastewater to a river, and that wastewater might not necessarily be well treated for whatever reasons. We know our wastewater treatment plants in South Africa are struggling to meet the requirements. So a lot of raw sewage rivers as well. Now downstream there might be a town that wants to use this water for treating it for potable reuse, but you can't really classify it as a surface water anymore. It is now contains such a high content of wastewater that it can be the same quality as a normal reuse feed water. So we say that those plants can be considered as de facto reuse plants, because they now have to make treating all these other micropollutants that end up typically in wastewater, your pharmaceuticals, your hormones, your pesticides and things that you need to get rid of. So in effect, in a practical sense, that would mean your normal conventional water treatment plant in Paris would need to be upgraded, for instance, to be able to treat the Vaal River coming down of a poor quality. So you would need some more advanced treatment processes like membranes or activated carbon or advanced oxidation or the like.
Thank you very much, Chris. Now, still staying on the topic of potable water reuse, I want to move over to you now, Megan. And I mean, having coming from Umgeni Water, so I wanted maybe your view on really what informs the technology choice if the water is intended for drinking purposes. What informs the technology choice, and also what sort of quality control measures are put in place to make sure that the water is safe for human consumption?
Thank you. Yeah, so the first thing that informs our technology choice is definitely public health. That is our main mandate as a bulk water supplier. So if you're going to give people reused water, public health is the first thing that informs your technology choice. And then as a parastatal or part of a government entity, you want to innovate, but you also want to use known technology that has been tried and tested elsewhere. We have been moving forward now into more innovative and technology that's not well used, but our first port of call is to use known technology that has been used. And then also in terms of disposal, there's lots of legislation regarding disposal, and obviously we're worried about the resource. So being inland, whatever technology we use, whatever waste we have, we can't just push it out to sea. You would have to do something with it. So the next thing is, if you're looking at reuse on a large scale, we have to look at the complexity of the technology. So in terms of what type of operator skill do we want, because we would need to employ people, and people that are already employed within our system of normal water treatment. And then also we need to look at our South African context. We have our issues with HCOM. So we need to look at how much power we use. And when you're moving things into implementing things in rural areas, how easy it is to use it. Would you be able to access it remotely in terms of getting feedback from your process? And then we also need to ensure that you have enough buffer. We need to look at the risk in terms of getting impurities in the system that are going to go out and cause health issues to the people. So we need to verify the technologies and verify each unit at every stage. So at the moment, Mgeni has a small reuse demonstration plant, which is a 2 meg plant that is going to be taking into account these factors and testing certain technologies. We've also partnered with City of Cape Town, and eThekwini Municipality is one of our customers. So they have already got reuse projects that are currently underway. So City of Cape Town have a direct reuse project that's going to feed their big fodder plant, and eThekwini, as mentioned by Benoit Leroux, they've got their remix project. They're looking at bringing on 4 new projects as well as the existing Meerwend project that they're using not for potable but for industrial reuse. So what we would like to do is also to be able to be a center whereby people with existing systems, so the technology that they already have in place, if they're having challenges, it's also a place, a small pilot place that they can research their challenges and possibly come up with some solutions. Sorry, I'm just jumping on I think it was Henny's comment about potable reuse is not the best way, and fully agreed. Where we can take pressure off our surface water systems for potable use and reuse water for example, industrial plant process water reuse. You're definitely adding to water sustainability because we have more water to drink, essentially. So I don't know if I've answered your question fully.
I think along what you've said, you have definitely. All right, thanks very much, Megan, for that. I want to now move over to you, Achim, in terms of mining as well as industrial water use generally. So you mentioned a number of projects that are already up and running. So maybe can you shed more light on what some of the success factors have been for this project to have been running this long till today, and also for some of the projects that you gave examples to also shed more light on what the water is used for. I see a comment from Edwin Mamecha. He's really asking or wants to know where really industrial water, the water that is reclaimed from industrial wastewater, is used for agricultural irrigation, to ask if what are some of the enabling factors? Is there a regulation, or what are some of the steps that would enable the reuse of industrial wastewater for irrigation?
Okay, a lot of questions. Luckily, I started jotting them down. Otherwise, I think I might have missed.
Don't worry, I'll be here to remind you.
Thank you. Let me just throw in a question to Megan and Chris and to you, Club, to think about in the meantime while I answer your question. Something that I noticed that was declining for quite a period after we initiated the first big mine and water reuse projects was South Africa's capacity to do lab analysis in South Africa for the stuff that we need to do for reuse. We can't wait for 1 or 2 days for samples to be sent overseas to get, because by that time the sample is no longer representative. So I'd gladly have some feedback on that later, but let me answer their questions. So success factors: willing participants in the reuse project. So on the mining side or on the industrial side, you've got a client. They must see the value in it. So you must demonstrate to them that from a financial, from environmental, from a sustainability, from a good citizenship or good corporate citizenship perspective, that there's value in doing these projects. And then they obviously very often bring the finance side to it as well. Now, the mining houses generally have access to finance maybe a little easier than the municipal or public or even private sector side, or individual side have. But you need that willingness from all the role players. At the time, we also had the Department of Water Affairs at the now. You need them to be in a position to actually make decisions for water use licenses on all of this. And then we technically followed all the good practice things. We identified various technologies. We did pre-feasibility and feasibility studies on those. We did piloting. We made sure that on the pilot plants that it works, that we understand the technology, that we know how to operate it. Start training operators on your pilot plants already, because that you're going to need them later on when you start commissioning a full-scale plant. And then obviously do all your analysis to make sure that the water quality is right, and feed that all back into public participation processes so that the people are on board with what they are signing up for, the people that are going to be using this water afterwards. There was a question around water use. A lot of the mines started where they could reuse their own mine water be it for reuse in coal wash plants where you only need partial treatment, be it for dust suppression on the sites, any possible opportunity that they had to displace otherwise clean surface water that is easily used for industrial or potable use. They try to reuse their own water internally before they then went to the next step. Now our mining complex has gotten so big, we've got so much excess water, we cannot manage our own excess water just by internal reuse. We now need to go for potable use and then make it available to outside parties. And their legal responsibility only lies in getting it clean enough to be able to discharge it into the water course. But a lot of the mines identified that it's actually our neighboring communities are struggling with water shortages. Why not go that small little extra step? It's not much of an additional cost for stabilization and chlorination, and then this good quality water can be made available to the local communities and solve a lot of problems there with water availability and capacity constraints in municipalities to run their own water treatment plants. In terms of industrial reuse, similar things. You get a lot of resource recovery. Sometimes you have a water stream with a lot of organic material. You don't want to pay, even if you're taking the organic material out of the water, you've got to now pay a lot of money to dispose of it. So why don't you just digest it on site, make gas, the gas you can use for electricity generation or heating in the industrial processes, and then you get a much smaller volume of sludge afterwards that you need to dispose. So those are just options. There are techniques like pinch analysis that can be used within industrial process to optimize your reuse without needing treatment. I know, Chris, you called it a bit more recycling, but it's there's I think of it, reuse is you directly reuse as it is, and recycling is you have a certain degree of treatment in there. So just when I'm answering these, just take it out of that perspective. And then to go full reclamation is when you now bring it back to its original quality, which would be potable or as it was in the river. What are enabling factors? As I said, you need all the parties around the board to be on board with it. You need to have that public participation and buy-in from the communities. And I think we've seen it numerous times that if you have a community that's sitting with the water shortage and they open their tap in the morning and there's no water, and you then give them the option to, well, we can give you reclaimed water or new water, as they term it very nicely in Singapore. It just sounds a bit better than recycled sewage, So we need to look at what terminology we use to make it more palatable for the public. But as Megan said, the one non-negotiable is the quality's got to be right. That's your easiest way that you lose public confidence in it, and that you shoot yourself in the foot in terms of a team implementing projects like these. So, yeah, I think I've covered a lot of them. Anything that I've missed, Nhlanhla?
You were spot on. You covered almost everything that I asked, and even more. and thanks for that. Yeah, I want now to shift a little bit and to, pick on the comment that, Henny mentioned at the very beginning, to say that there is so much focus on the recovery of water. So now, we've heard from the industrial side or from the mining side that there is a bit of some resource recovery. Now, Chris, maybe having worked with extensively in the municipal space, I would go as far as maybe modifying Henny's comment to say that there is just so much also on water recovery. How is the recovery of resources within the municipal space?
Do you mean whether it's sufficient and whether it should be increased?
Is it happening at the scale that we would expect it to be happening within the municipal environment?
Yes. Well, water reuse in municipalities has been on many years in the respect of the final effluent being used for irrigating golf courses, for instance, and so on. So if that is normally done with purified water or treated water, very expensive water, and I'll get to Henny's comment or somebody's comment about the price of water just now. If you can make that water available then for people to drink and use in households and rather use your wastewater, that's a good idea. So that's been going on. But going a bit further and directly treating the water for potable reuse, I think that is something that is, as I mentioned with the droughts, was really the drivers for getting the treatment plants. So if you don't have any other waters, then, you're basically, that's what you need to do. And we know with climate change and urbanization and migration of people all around, then it's very difficult for the engineers to plan in the future what the water demand will be for them to be able to plan for treatment plants. So a thing like water reuse, it's always available, or wastewater that water reuse, it's always available. So you can plan around that. The cost of that compared to desalination is lower because, especially if you don't go the reverse osmosis route, then it can be the lower cost. Obviously, for direct potable reuse, the factor that comes in is the health implication, whether you've got enough pathogens to make sure that you provide a safe water. So yes, no, I think Department of Water and Sanitation, they were still water affairs in 2012, 2013, thereabouts, when they brought out their policy reports, strategy documents for water reuse and so on. Made a good start, but I think that needs to be followed up now with actual regulation of water reuse and also, you know, especially the small towns which are still hesitant, but that experience, tell them, you know, about reuse and the possibilities. And I think that's good work that WRC is doing in terms of these guidelines that's been drawn up on water reuse so that the people have the necessary information at the municipalities to do planning. So there's a lot that can still be done. Just quickly, we haven't mentioned indirect potable reuse as such. We just spoke about direct. So indirect is where you basically, your water from the wastewater treatment plant and that you've treated in your advanced water treatment plant, you would typically put that back into a water source, which can be either in a dam above ground, a surface water, it can be aquifer injection, groundwater injection, like they're doing at Atlantis and also at Cape Flats. There's new projects now looking at treating wastewater and then injecting it into the ground, and then it can be reused after. Normally you would like about 60 or 120 days to give you some barriers against your micropollutants and so on before you withdraw it. And then you've got a water that is, from a public perception view, more like an environmental water than a direct water from a wastewater treatment plant. So I hope that answers to an extent your question.
Yeah, so certainly it does. It does. Thank you very much, Chris, for that. So we don't have much time remaining. We have about 10 minutes remaining. I have been watching the comments from the chat, and hopefully through this discussion, you are getting some of the answers to some of the comments that I've seen on the chat. But what I would want to do right now is I just want maybe to also do a last round to our experts to maybe give us a view on, I mean, most of you've touched on capacity. So I would really want to hear your views on, say, you, Chris, working in a municipal environment. Do we have the necessary capacity within the municipal environment to be able to implement water reuse? And if not, what are some of the things that need to be put in place in order to improve this capacity? And then maybe to Achim, what maybe I would really want to hear a bit more on is to maybe to talk about public participation. Is there a scope or an opportunity for communities, say communities that are around mining areas, to be able to participate within these water reuse projects? And what are the job opportunities that are there for communities? And then maybe lastly to you, Megan, also public participation is a very important aspect in the implementation of potable water reuse. And what are some of the things or interventions that Umgeni is planning to ensure that they educate and also they involve the public as much as possible in the reclamation or in water reuse projects? So I'm going to start with you, Megan, as maybe you still remember the question, and then I'm going to go back to the other two gentlemen. And also, just before you answer, Megan, I'm just going to ask also our participants to also pose their final comments and questions so that then around 5 to 3, then we can look at wrapping up the session. Right, over to you, Megan.
Yeah, in terms of potable water reuse, one of the major issues that we found was public buy-in, and we all know how public can stop a project in its tracks. So in terms of the projects that we are undertaking, the main focus for public buy-in for us is education. So educating the public in terms of what is water reuse, what happens to your water chain, and then also educating them to the risks that that are going to occur in the plant. So what we've done is on our demonstration plant, we've actually built a plant so that you can walk through, have a look at the technology, and then also have started implementing national reuse forums whereby people, academics, all stakeholders, so municipalities, water sector experts can come and discuss their projects, can come and so that there's overlap and we're looking at it holistically. So with a diverse set of stakeholders, you can talk to people's the issues that they might have and the challenges they bring up. So we're filling a gap and creating a solution to a problem that really exists. One of our main aims also is to target school kids as well as community leaders, because these people, they impact the thinking of the people in their households as well as in their communities around them. So this is definitely the way to go, is to engage people at a young age, and so they become comfortable with the technology, they're aware of the risks, and also to do our jobs well. So if you have a reputation for giving people good surface water, they will trust you to give them good reclaimed water. Yeah, thank you.
Thanks, Megan, for that. I'm going to move over to you, Achim, and I'm not sure if you still remember or you'd want me to repeat.
I do.
Okay. Yeah, if you can as well, if there's a comment there from Grant, so I'm not sure if you've glanced over it, but if you haven't, I'm going to give you then a little bit more, a few seconds to glance over it, and also maybe just provide some feedback there. Right.
Okay, let me just try and answer the first one and see whether I can answer the first one and scan through Grant's comment in a second.
Right.
The one problem though that we find, all the mines are trying to employ as many people from the direct neighboring community as possible. But because you are supplying potable water directly to a community to drink, the health aspects of getting it wrong means that you really have to have the right people with the right qualifications, with the right skills operating those plants, and that is critically important. So the number of posts that are available for your unskilled or semi-skilled workers from the direct neighboring community are unfortunately limited to what is needed on the plant. But I do know all the mines that I've been involved with, they are doing their best to try and employ from the local community as many people as possible. And they do send out requests for, if vacant posts become available, those go to the local community first before it's opened up to the wider community. Then on grants of water, or the increase of water use for manufacturing, I'm not sure what grants, but yeah, water.
Yeah, from what I read,
need
it's about just the cost of water for industry to rethink, maybe reuse, do more reuse, than probably maybe going for sort of water from the resource.
Yeah, I think as water becomes more and more constrained, if I'm thinking about the Eastern Cape at the moment in South Africa, those areas are highly constrained, and yet in those areas, clients that I've worked for in the past are bottling companies that are manufacturing drinks, and they need clean water for their drinks and what get put in the bottle for their washing and everything else around the site to make sure everything's hygienic for the bottling process. And for those sort of companies to remain in operation, they really have to look at reuse and recycling as much as possible. It's not a cost issue, it becomes the availability of supply and ability to be able to carry on with your operations constraints. So I think it is critical. that they start looking at investing in water reuse and recycling as far as possible, as far as makes sense, not just from a cost point of view, but from a continuity of supply perspective. And you know, with proper upfront engineering work, you can try and optimize or minimize the costs. Not optimize. Normally, you want to optimize. You want to make things more, but in this case, you want to minimize the costs and get as much water reuse out. And there are strategies around that that can be implemented, but it's very case specific, very industry specific. So I'm not sure if I've answered it or just caused more questions, but it's a bit of a short forum to do that.
Yeah, indeed. Even me, I'm looking at the time. We have only 3 minutes remaining. I would have really loved for Chris also to answer the question on building capacity in the municipal sector. And then I also remembered that you also asked us a question, which you were talking about the laboratory capacity. And you are quite right. And Chris would also know this, that the Water Research Commission has done a series of projects over the years to look at the laboratory capacity, to look at if we have the necessary human resources, infrastructure, analytical laboratory infrastructure for analysis, as well as the facilities themselves for analyzing samples. So really, it's something that really needs to be addressed as a matter of agency. And fortunately, I can also share that the municipalities have recently come together to form a network, what they call Municipal Scientific Services Forum, where really they have started also looking at the laboratory capacities, so that now they can start now putting in place the measures to look at how they can capacitate municipal laboratories, and also how can they capacitate in terms of infrastructure, so that they'll be able to also handle the kind of analysis that is required with these so-called emerging pollutants. So, I mean, obviously also from a national point of view, there is that need to actually put in place, whether it's regional laboratories, so that we can avoid that wait for 2 days for sample analysis. So with that, we have really run out of time. I wish we had the whole day to really speak about this very diverse and important topic. I would want to sincerely thank our speakers for imparting such rich knowledge on water reuse, sharing on the projects that are busy with. So thank you very much to you, Chris. Thank you, Akim, and thank you to you, Megan, for sharing with us today. So sadly, we have come to the end of this session, and hopefully there will be next time. Over to you, Rob.
Well, many thanks. That was I'm sure everybody will agree, it was a very stimulating conversation. There's possibly more questions than answers, but I'm certainly more enlightened now than I was before, which is a good thing. So I've gained personally a lot more knowledge on the topic. So now we move now into the solution showcase, and our first presenter is Mascom Water, and Annelies Cilliers and CEO Gerhard Gronier will give you a presentation which consists of 2 case studies. So I'd like to hand over to at least Annelies to start with, and perhaps she can introduce herself and proceed with the presentation. So Annelies, over to you.
Thank you so much, Robin. I'm just quickly going to share my screen and then we can start. Okay. Yep, just want to make sure that everyone can see that. Okay, so hi everyone. My name is Annelies Cilliers and I'm part of the Mascom Water team. Also joining me in the presentation and also for Q&A afterwards will be our CEO Gerhard Gronier, and we're very excited to share our solution as well as a few case studies with you of what can be achieved through water reuse. But before we start the presentation, I would like to first give you a brief overview of Mascom Water and what it is that we do. So Mascom Water was founded in 2010 by Gerard due to a customer inquiry with regards to a small on-site wastewater treatment plant. So he came upon the Karis fusion, which he then imported from the US. Since then, we've grown from strength to strength, and we have installed over 300 of these units across sub-Saharan Africa. We are also manufacturing these systems at our facility in Van Reinsdorp and exporting them back to the US. So our focus is on providing our customers with sustainable solutions. So if we look at some of the challenges that we're facing nowadays, there's day zero that is looming in the Nelson Mandela Bay area. Also, we have received some restriction notices, which is in Nelson Mandela Bay, as well as Gauteng, where they're actually urging people to reduce their consumption by at least 20%. Then we have developments that have come to a standstill in some areas, specifically in the Western Cape Metro, where they just cannot continue with the developments due to a lack of sewage capacity. So we have the solution that will ensure not only the restrictions in Joburg and the Nelson Mandela Bay is achieved, but also that developments can continue without any hassles. So what we're talking about is the Karis Fusion Decentralized Wastewater Treatment Plant. It is actually not a package plant. A lot of people get confused with regards to that. So the difference between the fusion from other plants, I'm just going to highlight a few of these, is that first of all, it's got low power consumption. It's got a low noise factor, easy installation, low maintenance. So when we talk about low maintenance, we talk about 1 hour every 6 months. And there's also no downtime during the service and maintenance. So we're going to move into the case studies now, and we're quite excited and proud of what we have achieved over the years. We're going to look at the Western Cape government. So they did a revamp at their offices in Cape Town. And with that revamp, we actually installed one of the Karis Fusion systems. They've got treated effluent that is being used for toilet flushing, saving them more than 1 million liters of potable water per year. So this is just to show you how we actually did the installation. As you can see in the top right is where we installed the system. So it's quite crowded in the middle of the Cape Town CBD. And then in the left-hand corner, you can see the area that was available for treating wastewater on site. This is just a street view, just to give you another idea of the availability or the entrance that we had to work with. And then on the left, you can see that was the space that they were going to revamp for the installation. Just then with regards to planning, we couldn't use one system, so we actually had to put in 4 smaller plants. The plant that we had in mind originally wouldn't have fit through the doors, so that's why we had to do the 4 smaller ones. This is the start of construction. So these plants are actually installed underground, which means that you do not actually lose any space. There we go, it's the final grade. So just to give you an indication with regards to when I mentioned the low noise and the no odor. So they treat the effluent right there, and then the doors are actually, the boardroom doors is actually 2 meters away from this plant. So that speaks volumes for what we have said with regards to low noise and no odor. This is the effluent used for toilet flushing. So the building discharges 8,000 liters of wastewater per day. 4,000 liters per day is needed for toilet flushing. And 50% of the water is saved by flushing toilets with on-site treated wastewater. Had they had gardens, we would have been able to make use of 100% of the water. This is just the Kango Caves, where we've got another fusion installed. So they're saving 3.5 million liters per year in potable and borehole water. So now this is a school in Kero Bloemfontein. They're also saving 15 kiloliters per day. So as you can see, they're making use of it to irrigate their sports fields. If we look at the solution overview, the thinking is to rather treat sewage at source, or as close as possible to source, and reuse the water for non-potable applications like toilet flushing, irrigation, water features, and cleaning hard landscaping. So the community will have increased water security for generations to come if we treat water at source and reuse it. This is the bigger advantage for them then. We're going to look at opportunities quickly for the fusion. Mascom Water does not install any of our units. Instead, we make use of other companies or people in the community. So in terms of local economic development, there's quite a few opportunities that we do have available. So we're going to, when it comes to sales and installation servicing, as I've said, we do not do the installations. And then with regards to new developments, they can still continue with their development. So when it would have traditionally been turned down by the municipality. Also, it frees up a sewage network capacity for additional developments. And then we're talking about water security, especially when it comes to areas where there's droughts. And we have quite a few of those at the moment. Skills transfer, we actually do support our professionals and upcoming professionals free of charge with regards to design and technical specifications. So there is support from beginning to end. Community upliftment, through making the treated effluents available for irrigating crops or a sports field, it opens up an opportunity for the community, to generate an income. So the benefit for the community is there for generations to come. This isn't just a once-off, put a system in and forget about it kind of situation. It actually brings opportunity to the community and it uplifts them. And talk about the positive environmental impact. Less discharge to overloaded or non-functioning municipal sewers means less sewage spills, which will have a positive effect on our water courses and groundwater quality. It even has benefits for agriculture. So there's a saving on the cost of honeysuckers to pump out conservancy tanks. More water is available for farming. And then farmers that want to adhere to the global gap and IPW will earn extra points by using the system. So if we look at what we said in the beginning, and we asked, or we said that these were challenges, we're looking at it completely different now, and we're saying, these are really not challenges anymore. These are opportunities to make a difference. If you have any more questions with regards to this, or you'd like to connect, that is my contact details, and we could have a chat and maybe have a more detailed discussion with regards to what the system does, as well as the technical specs. Thank you so much.
Hi, thanks, Annelies. And now I'd like to introduce Chetan Mistry from Xylem, Africa, where Chetan is the strategy and marketing manager. He's responsible for the go-to-market strategies for transport, treatment and usage water solutions in mining, industry, public utilities, agriculture, as well as residential and commercial building markets throughout Africa. So over to you, Chetan.
Thank you very much, Robin. Let me share my screen quickly. Hope you can see that. Thank you, Robin. Thank you, everybody, for being part of this great discussion. Good afternoon to everyone. It's just great to be in a forum where we're discussing reuse, which is such an important discussion to have. And it's good to see all the interactions that's been happening. Also, the great work, Mascom, great work on the projects that you guys have been developing. So good stuff there. We're at the tail end of our session here today. So I'd like the session to be very interactive. I'd like you to be using the chat box there to kind of elevate the interactions that we do have, and we'll jump into this in a second. So our topic for today, from my perspective, is reuse brew, and I'll take you through this in a second. So I'm sure, being the late afternoon, many of you would look at this and you're tempted, and it's already 3:15. We have been through many Zoom sessions, many meetings in a day. So just to get us into the interactive elements of today's session, I'd like you to please go into the chat box Tell me your favorite brand of beer. Where do you like going to enjoy your brand of beer? It might be at the pub, it might be with friends. Tell me anything that you'd like as far as these are concerned. Put it in the chat box. We'd like to see your engagements, your responses on this one as we continue getting some of those interactions in the later part of the presentation. While you're doing that, I just want to give you some quick random facts about beer. I don't know if you know that beer is made up of 90% of water. And interestingly enough, there's a beer that has 67% alcohol content in it. That's quite an interesting fact to have. And I know as South Africans, we might be a very beer-loving nation. However, the country that consumes the most beer per capita is actually Czechoslovakia, which is interesting. And did you know that in 1989, it was illegal in Iceland to drink beer? That would really stop a lot of people moving to Iceland, that was for sure. And then in Austria, there was a brewery that allowed you to swim in a pool of beer. Quite interesting, isn't it? So looking at this, I mean, it's tempting. We all drink beer, or many of us drink beer, and we look at this in something that's really refreshing. But let's change it up and see. Would you be willing to drink wastewater, something like that looks like this? It's quite challenging mindset to have. Never mind drinking something straight from this, which is coming straight out of a Fear Factor movie. But what about if our local beers are made from the same wastewater that we have available? So with this kind of thinking, we kind of challenged from a Xylem perspective, this mindset. And we had this notion to try and develop something novel. And we came up with a solution called Reuse Brew. This brew is made 100% from wastewater, which was quite interesting that we had developed this in Berlin. Interesting why we'd have driven something like this. We thought of a novel way of doing something to demonstrate the good use of wastewater. And with knowing that beer, for good beer, you need good water, we came up with this novel method of going about this. Associated with this is as well the good times associated with beer, the social gathering, the leisure, the universal appeal of beer coming from sophisticated craft beer to local home brews. We thought this would be a great way to demonstrate how reuse can be put into action. So with this, the mission was to take municipal wastewater and produce something pure out of it. To drive on this real mission of ours, we had a very collaborative approach. The collaboration was with the Berlin Water Public Utility, as well as the Research Center in Berlin. And of course, as Xylem being an OEM and a technology provider to bring about the best way to bring the solution to market. So the process that we followed is quite interesting. We started off with the conventional treatment method that is using mechanical and biological treatment that separated the solids and removed the organic matter like phosphates and nitrates and the microorganisms like the bacteria, viruses, parasites, etc. And the final effluent that came out of this conventional method was dischargeable into surface water bodies. So it already gives you an indication of the purification that takes place. However, this water still contains organic micropollutants and pathogens. So over to the next process, which we call Xylem Auxilia. And this has two parts to it. The ozone oxidation, which is it's a strong oxidant as ozone. And the benefits of ozone being that it can produce on site and on demand with very little resources. All you need is air and some power. So this makes it a very practical solution because it eliminates things like using chemicals in your oxidation processes, etc., and from your purification processes. And also that ozone reacts with the organic material and therefore transforming it into non-hazardous contaminants. So this way it also eliminates the pathogens. From the BAF, or the biological activated carbon filter, we had the biological post-treatment, and these processes in combination created purified water so that it can be it can be discharged into sensitive aquatic systems. We then took this to a reverse osmosis or the RO process, where salts and other organic compounds are removed. And this went through a semi-permeable RO membrane to remove these elements. The result is that the water had low mineral content and alkalinity and similar to distilled water. The next part of the process was advanced oxidation. And this is the final safety barrier of advanced oxidation, which uses hydrogen peroxide and ultraviolet irradiation to produce hydroxyl radicals and remove 99.9% of pathogens and other residual chemicals. And the last part was to make sure that the product was actually, the water was tested and brought up to the right levels according to the standards in Germany, which also complies to the EU standards. So this process goes through a lot of the technologies that are available through Xylem, and a lot of our brands that are associated with the treatment portfolio, such as Verico, Leopold, Sanita, as well as some of our testing equipment, such as the MGK solutions that we have. All of this, we complied with all of the safety standards and regulatory processes that are there in Germany and the EU laws that we complied to. And this was critical because obviously producing something that's going to be consumed by the public required us to comply, but also kind of make sure that, that the product that we produce was safe for everybody. And the fact that it complied and that it could be a product that can be sold commercially demonstrates the power behind such a product, that it's safe to use, good to use, and beneficial from all perspectives, especially considering the reuse. This is a picture of the treatment plant, or as we now call it, water resource recovery facility, giving you some of the stats of the treatment plant itself. Just to demonstrate some of the components of the solution, this is the ozone solutions, and you'll see some of the elements that are there in a containerized format, which then spreads your mind on how the solutions can be dropped into different environments, not only at a treatment plant, but even at a localized regions, such as in industries, etc. Here's the biological activator filtration. So there's some of the other components as well as the UV AOP. So these are all part of the solution that we put together in the treatment plant. The response we received was incredible. You saw earlier one of these experts were talking about the behavioral changes, the block that is there as far as using reused water. And this has a major stumbling block from a behavior point of view, change of mindset point of view. But if you look at the response that we received in Germany, it was incredible. And this is what we're going to need to change, that reuse will be important as part of our daily lives now. We got to use the resources that are available to us, and that by recycling, reclaiming these resources, they are made safe and they are drinkable and enjoyable at the same time. As somebody who attested to the product of this reuse beer, as mentioned, it didn't taste like sewage water. And certainly, even though he didn't drink sewage water, he could attest to this. So it's an important element that it's that we have something that is as practical as this. So in conclusion, we can see that there's a rising demand for water and increase of scarcity of water, and the added pressure from climate change that is putting pressure on our water resources. And we'll have to drive to behavioral and attitude changes to wastewater, as this is becoming one of the key resources that we need to tap into. So this novel demonstration just shows that what can be achieved from implementing reuse strategies that we have, something that is reusable, that is practical, but also has the high quality of the end product, that we have a good quality beer that people can actually enjoy. We also have to take this outside of just the simple case study that we presented here and take the thinking broader and beyond this to other industries that will be that are critical, or even how do we deploy these into decentralized reuse systems to bring it closer to points of use, as well as for the purposes of water treatment. So even in this case, as an example, we used the water for the actual production of beer, but there's a whole lot of other elements in this process. As an example, the washing of bottles, disinfection, etc., that we can use water for, and we can bring this into our entire fold of thinking. Beyond that as well, we've got to look at reuse throughout the water cycle, as well as the efficiency of water usage throughout the water cycle, so that we can really harness as many opportunities as possible to ensure water security. So thank you very much from me. If you can get in touch, please, you can put your comments in. You can Google me on LinkedIn. You can find me and we can have further conversations. So thank you very much. Back to you, Robin.
Great. Chetan, thanks very much indeed. In fact, I'm sure that the members of the audience will be most impressed with both those presentations from Mascam and from Xylem. Now, to wrap up the session, I'd like to encourage our audience to click on the tab on the left-hand side for networking, where they can speed date with our audience and stakeholders, and also to visit the Exco tab, where they can get much more information about the whole process of water reuse. And with that, thank you very much for attending, and we'll see you next time, I'm sure. Bye.